until YouTube and Twitch catches up. Let me log into the YouTube chat. Actually, I can do it. I can just do it from here. Okay. Okay, it looks like Twitch and YouTube are live. Let's say hello, Twitch, exclamation mark on the Twitch chat. We have it on the screen. Great. Okay, let's wait like a minute. Go over here and say hello, YouTube, exclamation mark. Okay. That's great. Both chats are working. They're both on stream. Shall we discuss how we're going to be able to run a custom design on the Precursor trusted FPGA device? Okay, so let's kind of discuss a quick overview of what I hope to do with the Precursor. The Precursor, I want to be able to load in my own FPGA image. I still want the Precursor ecosystem, so I want to be able to Precursor to run and do all its chats just fine. But then I want to have my own FPGA image, which I can swap out on the fly and be able to do my own fun stuff. The goal I want to do is I want to have a microblaze system in there that uses the USB and connects to over there. It connects to a JTAG device, right? Like, I probably have something. Hold up. Here we go. Oh, is my video not on? Let's go fix that real quick. Activate. Okay, video's up. So you want to be able to use like a JTAG device like this, or the fancy other Digilent ones that over USB. And I want this phone to be a wireless JTAG device that can auto detect the device and perform benchmarking on the LUTs, the BRAMs, the DSPs, the transceivers, and be able to calculate the speed grade, not just of the whole part, but of the individual primitives of the part. And just be able, I want to benchmark an FPGA that way. It just seems like something that's not done, and I think it'd be cool. Where when you take an FPGA to the fab, there's different speed grades come out, right? Like speed grade 1, 2, and 3, but that's just a general like that FPGA met this expectation or failed this level. But there's going to be an FPGA that's the fastest FPGA of that type in existence, and I want to find that basically. Who has the fastest RTX 200T? Let's measure it and find out. That's kind of my fun little goal I have in mind. So let's see. We have a few steps to get this working. One, we need to be able to change the WBStar register, or the warm boot star address register, to be able to boot from a different address flash. Once we get that working, we need to have a USB driver, not from the FPGA, but to the FPGA, that allows me to do Xilinx, Vitis, debug over the USB to a USB packet to JTAG to microblaze debug module debugger system. And then once we got that working, we want to be able to do Vitis debug over Wi-Fi. Once we get that working, we can start working on we do benchmarking designs in parallel, but that's the hope. So it's a lot of work, but I think it'd be a fun project. So our first goal today is to add the WBStar feature to the Precursor system. And the best way, it's a Rust-based language. It looks easy so far, so we're going to do it in the simulator today and talk about the sequence and how to do it. So first, let's talk about the address in flash that we want to use. So if we go here, so this is the flash layout for the OS. A lot of it's already predefined and not very accessible. Like our largest flash location, the main file system, is not usable. It's kind of like this scattered encrypted system. We can't really go to it. And like an update staging error. So what I want to use, what I think is we could use the padding area if we wanted to. That might be a good place to hide something. But I was thinking of using the incoming FPGA staging area, which is the same region size as this, right? So this is 28, and this is, okay, there's a little bit more room in here. But we should be able to put a FPGA image in here, and as long as we control when it's updated, we can always just reload it over Ethernet, right? We could set up something where we can, anytime we want to do something, we can just upload the new swap FPGA image into here as a temporary image and then load from it. So that's the goal. Any questions to you viewers out there? So let's talk about how we're going to change this. So let me get the quick little system up and running. So this is my Linux machine that has it going. Do greps over here and get the system up and going. So let's show you the normal JTAG app operation within the terminal of the phone. Hopefully you can see this well. Okay, that's a good size. So if we type in JTAG, we have an ID command, a DNA, eFuse. The reset doesn't do anything. I don't know why it's there. It's bad. The burn 0 takes the eFuse keys and burns it to the eFuse, or I think it burns it to the eFuse. They don't have the, I guess, yeah, it burns it to the eFuse. We don't want to burn the eFuse. We want to use BB RAM, but whatever. We have a WBStar function, and I just added a placeholder. So let me show you what the WBStar function currently does. The WBStar function says hello world. So now we need to implement what this does. There's a few places let's talk about what files we changed. Currently, this simulator doesn't actually give you like the correct ID code or anything, but we're going to work on that. Pull up the Be Trusted IRC room. Okay, so let's talk about what we've done so far to get to this place. So the few files, the commands, the JTAG, the JTAG commands right here. So over, and I think this is all the files we need. Well, we need a few more, but we can work on these ones. So this is where we define the shell commands for the script, the terminal. So I added a WBStar here, and down here I just had it print hello world. I don't really know why the right has an exclamation mark. I don't know why there's an unwrap in here. I am not familiar with Rust as a language. I'm just kind of looking at the other lines of the code and saying, I hope this is right. Hopefully we get some experience. We have some bugs coming along the way. We can try to figure it out and maybe look up some Rust tutorials along the way. Okay, so where do these commands go? These go to the librs, right? So back to here. So when we call, let's do get ID code, right? So self.jtag.getID looks like Python. That get ID command goes to the JTAG librs, and it calls this get ID, and this get ID will call the opcode get ID command. This get ID opcode is defined in the API RS in the JTAG source folder. It has all these pretty little commands, and then it goes to the main RS. There's a beautiful little loop here, a little service. We have a service, a JTAG service running in the background. Okay. So this let's walk through what's happening here, and we can talk about the other fun files. So we have JTAG resets. This is going to reset the JTAG machine. Depending upon the tap controller, if you send a bunch of ones or zeros or something like that, it goes into this nice reset state. It allows you to properly get the tap controller into the IR section of the for JTAG. I spent too much time looking up JTAG stuff. So it sends. So this is the IR code that we are putting into the JTAG, and so you push the U32 onto this FIFO, and you hit add. I think this is a FIFO. Not really sure. Maybe we could add multiple commands and check. I don't know. Let's see. Is there a? We look up here. See if there's actually like a large FIFO. That's the pop. Here we go. But how big is the stack? Try and count. Assure count is less than 30. Okay, it's right here. Push will take data from an unsigned int and append it to the JTAG input vector. In preparation for sending, count specifies the number of bits of the vector that are valid. Indians specifies that the MSB should be pushing the tag. In this case, the count is less than the full data length, and the first order is requested. Okay, so I guess we could just keep pushing stuff. Okay, that's fine. We'll figure it out. So back down to how our JTAG system is working. So we are going to do a push command of 6, even though it's max 32. Add it to the JTAG next, which is I assume putting in there, and then it gets the output of that next push command. We want to make sure it's 0 because it should be 0 or something, or is none. Exactly what that means in Rust. I guess it's zeros. And then so this is the IR command. Now they're going to do a DR command. We're going to push zeros, 32 zeros into the DR. Boom, boom. Debug reset. What's the debug reset doing there? Didn't see that last time. Okay, I guess it does not matter. The debug is set to 0, I guess. Okay, then we push it, and then we get debug get into D. Oh, it's just a quick D. It's just using that for the trace data. Interesting. Okay, so that's just some debug. Need to figure out how to get the trace log. Okay, so that's basically reading the IR code. So we have IR codes. Where do we find these? How do we know what IR codes to use for our FPGA? They're not same across all FPGAs. So we want to look at what's called the BSDL file. The BSDL file, there's an individual one for each FPGA. And each of these gives you the pinout and the skip. We'll go down. Gives you, but the middle gives you the IR codes. So these are all the IR codes supported by the Spartan 7 and FPGA. So the Spartan 7 FPGA has the ID code. bypass, and xtest. So these three are the only required commands for JTAG. Everything else is additional features. Xtext is pretty cool. You can actually change the IO pins. So you don't see a WBStar here. The WBStar is actually using these two. We use configure out and configure in, and potentially these ones if we want to do some fancy stuff. But we're going to be doing config out and config in. If you ever want to look at how the xtest works, it has the okay, well, down here that's where the ID code is defined. But down here, you use these pins to be able to rewrite the output. So you can potentially spoof the FPGA output without having the FPGA stream. Okay. That's it can be really useful. I want to get more into this. I want to be able to. I have a project in mind where I might be able to take advantage of these I/O pins. Are these BSDL Xtest I/O pins? It's really cool. Okay. So that's where we get the IR codes. So now that's not enough. We have to use the configuration in and configuration out to look at the read and write the WBStar register. And this is where the almighty Series 7 configuration guide comes into, right? Series 7 configuration guide. There are new readers release. WBStar. Right there's a good example. But let's find the example by itself. Okay, here is an example command of how to program the FPGA or the write to the WBStar register. And it's kind of simple. You have the sync word. You don't use the dummy word in this situation. You have a sync word. You have the no operation. You have the write type 1 packet command with the WBStar address. So the 3 is the write, the 2 is the WBStar address, and the 1 is how many words. And you write the WBStar address, in this situation 0. We can ignore the iprog command in this situation. I want to try to use the normal boot up in the Xous system, and then you can do like a no up or something afterwards and get out. The read's a little bit different. There's a read command, then you switch to configuration in and read. So if we go back here, I've created a kind of a template for the get WBStar command and the set WBStar command. So first, we're going to do a get command. No, first we're going to do a set command, then we're going to do a get command. Let's try that. The first thing we're actually going to do is there is a check if there's some additional tokens here. So we're going to take this little additional token command here and add it to the WBStar. How did it help? I would say do JTAG WBStar. The syntax look. We're going to do get, and then we're going to do set address like that. Okay. Now, how do we token next? I guess we call it a string. Oh, we can just do let help string. Okay, I think we just say let. Let's try to do that. In this situation, some val. I think we can just do val, right? Yeah, we have val. So okay, we're gonna say I don't think we want to do x. We just that. How do we do like a string? Okay, yeah, I don't. Yeah, looks like we can just do that. Okay, cool. We're just gonna say right here, not implemented yet. Exclamation. Um, I don't think that's right. Another one there. Delete. Okay. Go here, kill this, rerun it. Get an error. Oh, there's an int val. We want just val. Oh, I am programming the software. We had a question. What am I programming? I am programming the software for the Precursor Spartan 7 FPGA so that it can do a WBStar command over JTAG and change the boot flash address for the FPGA. Thanks for the question. Okay, let's bring this over here. So we'll type in JTAG, wait a few seconds. You can see the command back here in the terminal underneath that it saw it. Hit enter, it ran that. Okay, cool. Let's try JTAG WBStar. Okay, so we do JTAG WBStar. Yes. Hello world, Git not implemented yet. And we do JTAG WBStar set 0. Cool. It's the new line. I think. Guess it doesn't matter. Like they really have lines here. Cool. So we're gonna work on the Git. So we're gonna do a match val. Well, here let's do we got any command. We have a sub command. Go the sub command. Well, the sub command. That makes terrible sense. Woohoo! Okay. So let's see. Let's play around. So let's do match sub command. I'm going to do underscore equals right. So I'll put that here. Okay. 3 more of those. But this is gonna be Git. Well, let's do this. Yeah, we'll do a Git. We're going to Git set Git set. Yes. Do a Git first. Then we'll do the set. working on that. Say, what about it? Cool. Let's see if that builds. Argument never used. That's oh. What a nice compiler. Oh. Oh, let's put it in. Okay. Go back here, kill it. Okay, now it's happy. Let's see what we got. JTAG WBStar. Hit not implement. Great, great, great. Set. Oh no, supposed to be. Why is that not working? Not get those values. This not very. Oh, that's why. Use the other command. Okay. So then after that, we'll need to oh, it's resizable. Make it big. Okay. JTAG WBStar set. Working on set. JTAG target. Okay, cool. Fine. Okay, so what's next? Let us okay, and here we're going to do set value. That right there and say can't set W star but set value there. Okay, the rest is interesting. Okay, JTAG that. Oh, hello world, JTAG WBStar address. JTAG WBStar set 1. Okay, I think we are ready. So what we need to do is then call a command. Doing it to. Okay, let's look at some other command. Is there? Where's the good? That command, good one. PC get. If some URL. They. That's the good one. Here's a good example. Sleep. Oops. Well, the help string is at the top. Maybe you can find something. Debug string. Okay, not there. RTC command. Mtest. Mtest. Mtest iteration. Okay. How is iteration parse U32? Else if that might be what we have to do. Um then for all the commands. Not really good examples is where. Play info. Play. Next. Okay, so memtest, see if net command. If we scroll back up, estimation socket. Look at that UDP PX. Or count. The UDP token. Next. Socket. Token string. Sure. Okay. I'm dividing it up. Was ping. So count. Where does count coming in? Count. He parses the 32. Yeah, I guess we're just gonna have to see what happens. So I guess we're just going to copy this and print it out. Okay, so we have a value here. Then let's see if this matches. Okay. Seems kind of boring just trying to get it all up and running, but gotta start at one end before we can go crazy and test everything out. JTAG WBStar set 000. Does that parse well? Failed. Still shutting down virtual process. Okay, so let's try again, but we're gonna do a 0. We didn't like that parsing. That'll be a good way. Let's see. Rust parse hex string to a decimal integer. So from string text, that what? Okay, I guess we could try that. Let's try this again real quick just to see if the JTAG WBStar set. Okay, cool. So we wanna put a 16 here and a U32 set value to int value. So let's see if the X works. You may have to trim. Trim start. Okay. Okay, let's see if it works. So we'll try with it. JTAG WBStar set. Look like that broke it. So let's do this wonderful trim, right? About prefix. Put set value into raw without prefix there. Okay, cool. Run. The other portion actually should be relatively too worried. Okay. JTAG WBStar set. So beautiful. So the address we would want to do is going to be 28000 set 0 28 8 1 2. There we go. Okay. I think we're good. Now let's pass that function in. So I'm not sure why everything needs an. Oh well. So we're gonna write WBStar. Input value. Okay. So I think first we want to go to the API. Actually, yeah, API. Just there's a way. I don't know my command well enough code to just duplicate a line real quick. We'll just add a read y right here. Okay. So we're gonna do copyright IR. Right WB star that just, oh, that's what it's called. We're gonna say address U32. Let's say WB star as um or that just automatic sizes it. Right IR, get DNA, new blocking scalar. This is the new scalar. So I guess you're not blocking this situation because it's pretty straightforward. Okay, sure, sure. Yes. So get DNA is blocking scalar to 0. Okay, so we should be good to do the right one. Should we do it with or without? That's correct so far. And dr command. Okay, so let's try this. That should work. And let's add a command here. It says they did it. Okay, so 526 of main was not at 26. Oh, okay. Not doing that one yet. Get out of here. We'll worry about you later. Make my life harder for me. Interesting. It saw that we opened files. Looked around or something? I don't know why it's building all of those. Method not found JTAG. Right WBStar, right WBStar. So, where are all my instances of right IR? So, or we'll just do, what's the good one? Get DNA. Sounds like a fun one. CD, get DNA. So it's in lib, and it's librs. That's literally it. Oh, what's this? So I have a right W star here. Did it match? Literally, where else it could go? Maybe here, the current scope. Do I need to go further up? Didn't see it anywhere else. If I do write IR, is it happy? Okay, so it's they're clean. Turn nuke. Run. Wait, we're doing run, clean, cargo. Maybe it's weird. Um, why, public, turn, turn. There's a pub in front of it. There's that weird map at the end. Maybe it doesn't. Which one is this? It's send message. Yeah, I don't know why. Oh, what's that do? Um, hopefully easy. Hmm. The right IR anywhere else? I mean, so we have two places for right IR. In public. Yeah, yeah. So that's gonna only be the only place I see. Compiled JTAG service fine. Maybe it just didn't recognize the file change. We will, I guess. It's this hurdle. It should be like the last main hurdle. We can at least write out a nasty version of the JTAG. Huh, why? We call it something scientific. Um, so close, so far away. Um, calling it a DR. See if that changes anything. Otherwise, you'd be unhappy. Oh, that would explain a lot. Filing or something? Is it happy now? Why? Why did it work? We save it, compile, and then it didn't work? I don't know. That seems kind of confusing. Well, it looks like it's happy. Okay, cool. We'll try with a different command later, but let's see. JTAG WBStar set R200. You say. Scalar unpack row. Error J message expansion failed in mess JTAG server 6. Okay, which one is that? So that's gonna be the main, the 16. Oh, it's a blocking. Okay. That's why the IR command get DNA scalar unpack, and we girl fun exclamation mark. Yeah, message scalar address. Address here. Okay, let's change this again. W star. Go here. This to WB star. Kill this. Cool, unused. Okay, let's make sure we don't get an error this time, but we should be good. JTAG W star set 100 enter. Okay, panicked. Main 647. So we trying to do at main 647. Um oh yeah. This it's gonna be unhappy with this. Um you want to what's the end of the radar? It's it's not. Okay, I think we can just copy this. In all honesty, I just say we just call JTAG. Actually, it doesn't even matter. It literally doesn't matter. We just hit next. We need. We don't need to debug. Do this. Actually, do this. But okay, let's see. I want to go see this ad up here. If there's a 5, so did it pending queue? How big is um how do we need to change it? I don't think so. Okay, whatever. Okay, let's build this real quick and then play around with the other values. But yeah. Okay. Kill that. Rerun. How do we say recast IR command? Okay. As U32. Not sure what U size is. What is U? Rust U size. What is whatever the pointer size is apparently. Okay, cool. Probably just default large size. Okay, JTAG and WBStar set 200. Cool. Okay, everything's happy. Let's add the rest of the commands and probably call it a night. So what we're gonna do is gonna copy this. Let's just call it a JTAG get, right? Just flush it. I don't know. I don't know if we need to. We'll have to read into that. Just copy that here, place that, take numbers. Okay. You unhappy with that? Get better. Otherwise, Rust can't hex numbers. I will be upset. Okay. Copy that. And we're done. Let's see if this builds. This builds. We'll call it a day. Um, oh, it is not Python. We need semicolon. I assume it's just clearing off clearing whatever's off of the stack. Invalid GG. Oh, sorry, that is my bad. It is not GG. Should have noticed when the other numbers are colored. The values. I think configuration guide. Where are you? Configuration guide. AA995566. 566. I don't know where that came. Okay, cool. Um, we, I guess, sure, it's not a big deal, but I was hoping that would not be needed. I have to read up into it more. Let's just get it functional. Call it a day. Whoop-de-doo. We'll make a fork. We'll make a fork. That will be our final thing. So git change to fork. How to move to fork. Cloning. Fork the repo on your fork their repo. More to your fork. Push your git fetch fork. Oh, okay, this seems pretty easy. Yeah, we'll try that. We'll have to do that within the VS Code. Okay. Okay. It seemed to have worked. Let's make sure it doesn't break. WBStar set. Ugh. Okay, it's happy. So let's go ahead and fork that. Fork. Oop. Great fork. Only take a few seconds. We'll push it, and we can add it to let's get remote add my dash fork, paste, boom, git fetch my fork. We make a branch. Just git status. Unbranch main. I like how it's main, not master. Yeah, that's us. Let's just, I think we'll just keep it on main for now, I guess. Git push. Oh, we gotta do a git commit. Git commit dash am added JTAG WBStar set. Git push my fork. Allow. Might not be able to push. Okay, it's coming up. Well, thank you. Okay, cool. So let's go back to I4. Yep. F5. Okay. Well, thanks for joining me. Next week we can do. I'll probably get the git command done off stream or on main video. Next Wednesday I want to look at doing the USB debug core, which will be fun itself. We'll use the Arctic Ultra Plus board for that. But thanks. I think that's it. We about 1 hour. That was the plan, and